Hi guys, my name is still Ryan, but I have gotten Windows since we last spoke, which was yesterday. Um, I It was actually 2 days ago. I was just watching my other video for no reason or because I'm weird, and I was like, I'm just gonna make another one. Um, I don't remember what I was doing before that. I think I was trying to write some code for my library and clean some stuff up, but I wanted to talk more about Scratch because I feel like eventually I'll get through everything and then I'll be able to like have all that in speaking, because there's still so many things that I kept thinking about when I was watching. Um, so actually, let's just look at something. I don't want to look at the same project. Let's look at this one. This was another one that took me a long time. And also, let's look at it in Turbo Warp. And I just want to know, okay, a few things that I noticed. Okay, I like to do this like anti-crash thing, which was fun. Um, let's give it high quality pen. This application is, I think I might have showed it in the last video. It's it does polynomial interpolation with arbitrary number of points. I think you can add points. You can calculate the coefficients of, so it makes a polynomial, right? A degree x, where x is the number of points. So if you have 2 points, oh sorry, x minus 1, I guess. If you have just 2 points that I don't remember how to get rid of, how would you get rid of a point? D for delete. That's not it. Hold X and click on a point. Boom, boom, boom. This is just a math that I used to be into. 2 points makes a line, right? You can define any 2 points, you can define a line that goes through it. And for any 3 points, as long as they're not on the same x like this, you can make a parabola. So a degree 2 polynomial that goes through all these points. And then it just, it's the pattern from there. And this was super fun for me. I was into like some ways you can encode data with polynomials for a little bit, but then I got bored because math is boring. But I made this project to visualize the Gregory Newton polynomial interpolation, I guess process algorithm maybe. I watched a mathologer video about it and I was inspired to make a interactive application. And I used to love to do these kinds of things when I had free time and passion. But it was in Scratch because this was 2022 and I still considered Scratch to be the fastest and easiest way if I wanted to make something like this. And it actually uses an old version of my text engine that looks really bad because it doesn't have Bezier curves. So it's just all blocky and angular, but it is really fast, at least in Scratch terms. But I wanted to look a little bit at some code. I haven't looked at this in years, so I'm not going to know what is going on at all. But like we can see some examples and kind of compare it to what I would do later in other languages. So number one is that like Scratch is kind of an IDE if you think about it. An IDE, an integrated development environment. It's a place where you put all of your code. This is like VS Code's like a lightweight IDE, and if I was using it correctly, I would have opened a folder, and I would have. Let's open up OpenGL. Let's do this one. And it will have extensions. This is how VS Code works. It'll give you what's called a language, LSP language. Sure, I don't remember what LSP stands for. Basically, it just helps you out, allows you to do some things like shift click on things to see their definitions, or let's actually make that useful. If I go to here and I wanna do that, or you can hover over these things and see all their arguments. And for most people, if they like, it'll like do a little autocomplete. It doesn't do it for me because I turned it all off because I didn't like it, but it is pretty useful. And that's all the things an IDE will do. You put your code in it, you can write your code in it. Sometimes you can even click a button to run it. Like I know the VS Code has a terminal built in that I never use because I always just use this one. And this is a PowerShell terminal, and I literally never use this. I would be using the command prompt if I was actually like that. You can compile and do whatever. Can I run it from here? I've never done it. I'm assuming you can. Why not? Yeah, there it is. Here's another example of a more in-depth IDE. This one is used for programming microcontrollers, specifically of this brand. So if you want to put code onto an STM32 microcontroller, this is going to be your default option. It's software made by the same people who made the microcontroller, so they work with each other. And this has a lot more stuff. It's bigger, it's like bulkier, it's got more stuff going on. And if I start, and sometimes it actually even does the little box that pops up when you try to type something. And I don't know when or how it decides to do that, but it kind of sucks. I don't like using it. It's based on Eclipse, which is like an old IDE that's from probably the 90s and doesn't look very good. And I've done a lot of work to make this look a little bit better, but like, look at all these buttons at the top. When you see this kind of stuff, and when I first installed Visual Studio Code, because some old guy that I met in real life was talking to me about it because I was into Scratch, and I was like 15. I installed Visual Studio Code because he was like, you should do that. And then I get in there, and I don't think I even have, not Visual Studio Code, Visual Studio. Sorry, very big difference. I don't have Visual Studio on this computer because I don't use it. I get in there, it looks kind of like this, not quite, but you know, similar level of application. And I get in there, and I see all these buttons and all these windows and like a console and like this stuff going on, and I'm just like overwhelmed. It's kind of the same feeling you get when you first open software like this. And it just looks there's so many things going on, and you have no idea how to do anything. And I think I just crashed it. Okay. Don't know why that happened. Oh, never mind. We're back. It's thundering outside. You get into here and you're like, what is going on? And that happens with IDEs. That happens with any like complex software, video editing, 3D rendering, CAD, you know, Altium PCB stuff, all kinds of software that is big and has a lot of functions. Scratch is one of those. It's just not as big and has less functions. It's like that because you got like the sidebar here, you have the stage over here, you have all these different elements. It is one of those things. It's a web-based version of those things, but you can also get the offline version, which I have the Scratch 2 editor. But it is one of these editor kinds of things, and it's for code, so it is an IDE in a way, and I would say in the normal way. So it's just, you know, it's different. You know, it doesn't look like most IDEs. I mean, I guess LabVIEW, which looks terrible, and is way worse, and I would prefer Scratch all the time, but obviously they don't do the same thing. That's number one. Scratch is an IDE. Once you think of it as just another IDE, it might probably be your first one if you learned to code on Scratch, as I did. So you would have thought of it as like, this is just what coding looks like. Obviously you knew that coding was typing a bunch of stuff in text, but it's hard to, oh, it's really rainy. It's hard to kind of translate what you do here to what you do here. It doesn't look the same, but in noticing that Scratch is just a different looking kind of code editor, and runner and all kinds of other features that they remove, such as show me where all these things get called from, which they removed. Well, actually, let's take a look at the things that they removed that they shouldn't have removed. They used to have a define. So if I'm like actually, let's actually open up one of my Scratch 2 projects, which is not going to run at all. Let's see if we can find it. Programming Scratch 2. Oh boy. I have ability. Ooh, I don't remember which ones of these. There was a stick animator project that I spent so much time on right before Scratch 3 came out, and then it broke. And then it broke when Scratch 3 came out, so I stopped working on it. I was really into the stick fight type of stuff back then, and I think that's an editor. It's like Pivot. It's like I was trying to make a Scratch version of Pivot that's worse. And I think that I have some animations, which is kind of cool. Oh, there he goes. There's a YouTube tutorial for this punching animation because I couldn't do that myself because I'm a terrible artist and animator. But I just kind of copied a YouTube video and then did a bunch of coding. And the coding is the important part. And this thing is so slow. The offline editor was actually, in my experience, slower than the online one. Back when Scratch Point 2 was still around. I need to stop this project as well, which will not help. Okay, but ignoring that and assuming that you have a good editor that doesn't run at 5 frames a second, there were features like this. Boom. If I want to go to it, there it is. And why they removed it in Scratch 3, I have no idea. Like if I go to here, it's gone. Why? Was that necessary? Does Turbo Warp add it back? Maybe. Actually. I don't know. There might be a Turbo Warp. Add it back. But I haven't looked through all these. The other thing that it used to be able to do is if I have any... Oh god, events. Okay, start. Oh, this was a mistake. Okay. Okay. Yeah. We could... Can we still rename broadcasts? I don't know. Show senders and show receivers. This used to be so useful if you had multiple sprites. So this, it shows up yellow in the sprites area if you click show senders. And if I clear it, it'll go away. That means that both of these sprites will call start in some place in their code. Unfortunately, it doesn't like actually go to where it is. Show receivers, they both receive it. Do I have other broadcasts? I just clicked it. I didn't mean to do that. I have stop. Okay, this is great. It does show you what, it doesn't show you where they are, but it does show you what sprites things. And this is like an IDE feature. An example of that is like, it's like the search. If I want to search for turtle dot and position, I can see every place where it is, which is just like so good. And Scratch doesn't have quite as good tools, and for some reason they removed this one and the other one where you can just jump to a function. That's another thing about Scratch. Its code is not a text, obviously, that's like the main thing, but it's a 2D stage where you might write code, and the code has a position. So text has position, but it's on a 1D graph, right? It's up and down. There's only one dimension. If I scroll through here, I'll find everything. And I like to write my stuff in one big file because I used to write stuff in one big Scratch file. That's not exactly true anymore because I have these headers. But like all of my code is somewhere in here, and it'll be somewhere there. I just gotta like scroll and find it. Scratch, not so much. And I'm gonna open Scratch 3 because I can actually do it. Like you have to scroll in 2 directions, and that seems like a minor thing, but it makes it really hard to find things, and it makes it almost like when you're playing Minecraft and you know where everything of your chests are and you know which chest everything's in. Like when I wrote this and when I was working on it, I knew where everything was. I was like, okay, I need to find some function, some piece of code, or like where these things are, which like it could be in different places. I know where it all is. And especially when you get, and I have these like bits of code that I just comment out, which is, this is the Scratch equivalent of commenting stuff out. The actual comments are, I found to be inconsistent. Sometimes they just go away. But I did use them a ton, especially in my last project. We'll go to that in a second. So stage, it's got a stage. It's got an area. You get familiar with where your stuff is. And it's also like really zoomed in. It's not really that zoomed in. You can obviously zoom it out. But no one codes like this. I code in the standard zoom. Or at least I used to when I used Scratch more. And I would put all my code down, and then if I was looking for something that I just couldn't find, I might zoom out. And Turbo Warp is so good because it used to be, and even still, if I went in here, I'm not going to do it because I don't want it to save accidentally. Like it's actually performant with my scripts. Like I can actually move around. When you get big projects in the Scratch editor, it was like this. And Scratch 2 had these scroll bars, and you couldn't do what you can do in Scratch 3, which I'm glad that they changed that. Scratch 2 also still to me now looks more grown up. The Scratch 3 blocks still look baby mode, like Duplo Lego. Like this is like Lego, and this is like the Duplo version, and I think it's always gonna look like that to me. I think there's ways you can actually change it. Anyway, oh my god, there's lightning coming in through my window. So that's one thing. The workflow of the Scratch IDE is quite different from other, when you build software. It's going to look different, and it's going to feel different, and it's going to be difficult to move or to change. Like it's going to be a steeper curve when you switch, if you switch. So that's one thing. The other thing Scratch does is it's got lists that are one indexed, and this is not that big of a deal, but I do remember where I was looking back at my video, and specifically at that one project, which let's actually go to. Pro tip here, you can do that and it'll open. Anyway, that's not a pro tip, everyone knew how to do that. If we look at some of these lists that I still have in C, I still am one indexing the lists, so all the logic is the same. Here we go. They start with an N character or a null string, so they're one index, not zero index, because I'm a bad coder. Because it's all Scratch, right? So it's just all the logic copies from Scratch, and I didn't want to change the logic. Stuff like this, stuff like that, stuff like multiplying it by 3 for no reason, and I start I at 1 in all these loops. Literally every single loop for int I. It's like scary out there. I don't know if you can hear the lightning, but I'm on the 7th floor of an apartment. What was that sound? Okay. I'm on the 7th floor of an apartment, and it is pouring buckets and thundering super loud. All of these for loops, I equals 1. It's actually wild. This is, oh, not these ones. Who knows? This is the only project I did this in because this is a direct copied project from Scratch. None of my other projects, as far as I know, came from Scratch after this point. This was like me building this library in conjunction with building this project, and the library was kind of for this project in the beginning. Am I still recording? Yes. Okay. That's a little bit about Scratch 2.0 and Scratch 3.0's editing features, and then the one index lists. That was another point that I was going to talk about. Okay, I was going to go to this other project where I used a bunch of comments, and that was in this one. So I like how this is laid out. This was a project made in 2023 after I had been using a bunch of C, and I only made it on Scratch because I didn't know how to use sprites in C. Like I didn't know how to put an image on the screen with my C libraries, and I still can't do that. And I can kind of do that with the textures. Let's go to here. We don't need n for this, I don't think. So the comments, and if we go to the towers, you'll see a little bit more of that. Here they are. So this is what the comments in Scratch are kind of like. Nobody really uses comments in Scratch as far as I know. I'm not really big on diving into other people's code on Scratch, not anymore, and not for a while. I used to do it a little bit. I used to do it actually a lot. It is cool. Here's another thing. Scratch, open source. It's all open source. Every single thing, and this is like kind of the point, right? Like this, 3D. I was looking at this the other day. Like, it's open source in the sense that you can see all the code. That's cool. So, okay, Scratch is not just an IDE. It's also a platform. I touched a little bit about this with the whole, like, social aspect of Scratch. Scratch stock market simulator. I don't know what I'm doing. I bet this person has a pretty cool... This looks like that old trick that people used to do where they would stack. Okay. I don't know if it actually is. It's probably using the same technology that this project uses. Oh, I shouldn't have done this. Oh, anyway. There used to be this old 3D thing people like to do where they would stack a bunch of stamps on top of each other. Can I find it? Can I find an example of someone doing that? Maybe this is it. Maybe this is a good one if it is. Nope, it's just a render. Okay. I've been lied to. Maybe this is it. Nope, this is just a bunch of images. I would imagine. Yeah, look at that. Okay. 3D house. Not trooper. Maybe this is it. And I want to find this. I want to find this. Yeah, I think this is it. Wait. But those polygons look so real. Is this a bunch of images again? I think it is. I think it is. Come on, I swear to you that people used to do this. This looks like it might be what I'm looking for. Yeah. It's a bunch of cross sections of the thing and they just stamp over and over. This was pretty popular for a little bit. I guess maybe not anymore. This is 2015. I haven't really been keeping up. But I remember people doing 3D like this. You can only like rotate it 360. You can't look. I just put my hand on the screen as if you can see it. You can't look up and down. What was the point of, what was this? Comments? I was talking about comments before this. I didn't know how to put sprites on the screen in C. You have to use a library to load like a PNG or something. I wanted to load SVGs. I don't know if there's really that good libraries to do that because they can't be easily turned into like something you can just render. My turtle library could probably manage to draw SVGs, but it would be really hard to implement the spec, and I didn't want to do it. And anything that could do that would have to translate it to something that I could understand, and I didn't do that. Anyway, it doesn't matter. This project is a tower defense game. I might have showed it last video. It is after I was doing a bunch of C stuff, and my approach of just how I thought and how I coded probably had a lot of impact from doing a bunch of C. Wow, this is interesting. For instance, there is a memory allocator in this, and there's a heap in this sprite. One of these lists is the heap. This one. It doesn't get used unless you put down specific towers, in which case they need a heap allocation space, because they ran out of space in the normal tower list. This is how I use lists, and this is how I still use lists. I think I might be getting an alert telling me that there's a dangerous weather event. This list works by having a bunch of all the tower associated data with it. The tower itself, its position, its direction, I guess, is changing. Its range and its firing thing. and it's all in this one list. And I do this in C too, even though I don't. You wouldn't do it if you were being serious. You would make a struct, but the benefit of this is like I put 10 slots for each tower in this tower list, and that was what those comments were. So, and this kind of refers to what those mean, and they mean different things for different things. So the range, or the data, the range, and then it's got pointers in the list as indexes to other places, which, by the way, need to be updated when you delete one. All the pointers have to get updated. Well, not all of them, but the ones that happen at the end, behind the. It's a really messy and not a good system. But indexes as pointers and doing scratch lists as memory is like, this is what this project did for some reason. It was inspired by my coding in C. So this is built very differently than what I would have done prior to this. And I don't know if I would have been able to accomplish something of this complexity before I learned C, or without using some of these tactics. I probably would have had to come up with possibly the same, but probably slightly different tactics for how to achieve something of this scale. And that's something that Scratch, at least for me, was insanely good at. Independently creating or just coming up with the idea to implement a kind of strategy for what you're trying to do that ends up like being a real strategy that you might learn later, and just like having that as a bit of catharsis, I guess, is something that I don't know if it's unique to Scratch, and obviously it isn't, but I think that Scratch is very good at, or at least if you want to play with the rules of Scratch, like you'll find yourself being drawn towards creating these kinds of things and these systems, and you kind of have to make everything yourself out of these blocks that are static. These are the features of Scratch. These are the things you can do. There's a finite set of not that many things, right? You have a small rule set, kind of like Conway's game of life. A small rule set, a small number of functions, and you can build anything with it. You know, it's a Turing machine, and it's Scratch. And some of these things are complicated, more complicated than the rules you'd find in those kinds of other simple games. But the main principle of it is that it's like a limited set of things, but you can do anything. And this is what all programming languages are, but I think with Scratch it's like even more clear, because all of the things you could do are just right here. And if it was a new project, it would be not all these random things. They're all just kind of sitting here, a collection of maybe 100 or so things you can do. And with that, like, when you want to do something of a higher complexity, something like having this like window system, you have to just kind of do it all yourself. You have to write the logic that knows where the mouse is. You have to draw. In this case, I used the pen to draw it all. Deal with all of the edge cases and the minutia, all of the very fine details, because it all gets put back into these very simple functions. This is always the case for every language. You know, you compile your C into assembly, and assembly has probably like a lot of different instructions. There's probably over 1,000, especially in like the CISC systems. But you don't get to see that. With Scratch, that's all you have. It's kind of like an assembly language. It's higher level than that, but it's the same in the sense of this small collection of things that you need to build everything out of. And you don't have, with some exceptions, you don't have the luxury of just being able to kind of include a library like you do with Python. If you start learning to code with Python, then you probably will learn a lot better how to code with Python than I know, but you'll probably also be finding yourself relying on a lot of libraries, NumPy, or if you're into ML, you might use TensorFlow or use Pandas to read CSV files, or maybe you'll use Pygame if you're trying to make games or Windows and stuff like that. But you'll end up having these libraries where it gives you a functionally infinite set of these things on the sidebar, because NumPy is going to add another literal thousands of them, and then every package you include is going to have another bunch of stuff, which in the end all kind of becomes Python or probably C. Nobody knows how Python works, at least I don't. But from your perspective as the programmer, it's almost like you have an infinite set of permutations you can just type. It's not quite that expansive, but like you can type things that just happen. I remember in Scratch at my very first few times when I was first starting out, when I saw this mega block thing, I was like, wait a second, mega block? So I can just make a block and call it if touching other sprite, or if touching sprite bounce, because there's this block here which I still don't understand. If on edge comma bounce, what? First of all, what a wild thing to just have as one of the core, maybe part of the set of like 100 features, to have this as one of them, because it's so weirdly specific. And I wanted it to bounce if it touched another sprite. Like I had balls that I wanted to make them bounce off each other in 2D. And I was like, how do I calculate the direction the ball should be going? Because like, right, you point them in a direction, you move them, and then when it hits something, it's like, it's going to turn and go in some other direction. But if they hit at different angles, like a billiard ball, right, it's going to go in a different direction. I was like, well, the if on edge bounce like compensates for that. But also the if on edge bounce like is way easier because it's always hitting one of these lines, so it's just like an axis aligned, like either horizontal or vertical, so it's like two cases you have to go. But I was like, oh, I just make a block and I just call it this and then it will work. It's like, I don't know why I thought that would work, but then I realized pretty soon that it's like, oh no, make a block just means you use other blocks. It's not a free it's not a cheat code to just do whatever you want and just by typing it. That's not how it works. But if you start programming in Python, it kind of is how it works. You want to do something that is fairly common but not trivial, not something you can do with one line. You might, and in many cases you will, be able to just look up Python how to bounce two objects off each other. I don't think this is going to find anything. But now we have AI because the world is terrible. And the point of this was like, oh, you can find a library that does this, and I don't think there will be for something this specific. And you probably just find a Reddit or Stack Overflow thing where, okay, that was a bad example, but that would be my point. You have to build everything in Scratch. You have to build it yourself, and in doing so, you learn and independently create all kinds of like tactics, and some of which seem so, they're your first, you never learned about it, so you learn about it either through studying other people's approaches or just making it up yourself, like finding that out. And it's very intellectually, like, I wouldn't say empowering, that's the wrong word. It's not, it's like, it works your brain in a way that, like, I don't know if obviously I was a kid, so my brain was being worked in normal everyday life, just existing. I was learning because I was young, but like, it just was, and with all the time I had to do just Scratch stuff, it was just like so many things where you just get the deepest understanding. When you build it in Scratch, you have the deepest understanding. It's the same with C. This might be why I like C so much. C also is a collection of a small number, probably like under 100 things that you can do, some of which are weird, like Scratch, like a switch statement doesn't seem like the most baseline type of thing you can do. Whereas with Scratch, I feel like I like this kind of first principle stuff, this repeat loop. this loop is a forever loop, so fair enough, whatever, like an if statement. Obviously, these are really basic components. Some of these are less basic. Broadcasts and receiving is like, those aren't necessarily like base building blocks. Um, but, and like obviously a lot of the sensing stuff isn't base either. Like it takes a lot of API calls to get what this actually is in an actual computer. But at least it felt like there was some kind of, at the very baseline of it, you know, your basic blocks, your atoms, and you can build from there. C has a similar kind of thing. And there's weird things, switch statements and ternary operations that, you know, you can do in other ways, which is annoying. And it's like, I'd like to just not have those. But you obviously just don't have to use them. C, you can also just put libraries in, and it's even easier. Or I don't know if it's easier. I just think it's easier because I don't like Python. It's easier. You can just have compile with DLLs, and you can have includes, and you can compile with other flags and all kinds of linker stuff. And C to me felt like the first principles of a real computer, whereas Scratch is first principles of only its own system, right? Like Scratch code is never operable with anything else, and that's not true. Like literally that's not true, because now I think it's like it runs with JavaScript, and like if you make a JavaScript with TurboWarp, you can actually get it to like interact with things outside of the Scratch ecosystem. But for someone who was programming, and especially in the Scratch 2 days, it was a contained environment, and it was completely contained. Python, you can call C functions from Python and you can call C# with Python.net. And with C, you can call anything that has an applicable API and anything binary and all these different DLLs and around Linux shared objects and all those libraries. And it kind of like is anything a computer can do, the C can kind of do. Any language or terminal command or process is kind of open to being manipulated and run and called and operated with any other language. Python can do this, C can do this, anything can kind of like do all the things. But in Scratch, it's very self-contained. You can't get a virus on your computer by running a Scratch project. It's not possible. Actually, it might be possible. I don't think it's hard. It would be hard to do. I don't think it's possible to write some Scratch code that is actually a computer virus. That would be sad if you could, and it wouldn't be good if you could do that. So I don't think you can do that. It's very self-contained in that way. You can't call Scratch functions from other languages. Like it doesn't work that way. Maybe if you compile it to JavaScript, you can get it. And I know there's some extensions that interact with Scratch, and they must do it through some other means. And I don't know much about that, and I never really learned, because I kind of, once I started doing other kinds of programming, I wasn't doing Scratch anymore, and I wasn't doing the kinds of programming that would have interacted with Scratch, because I don't like doing web development or JavaScript or anything like that. Anyway, Scratch is its own ecosystem environment. It is a platform. It is a social network. It is a integrated development environment. And it one indexes their lists. And that's it. I think, no, there's more. There's more that I forgot. But I don't remember, so I'm just going to keep looking around at stuff. So, projects. Oh boy. Some Scratch history. We don't really need it. Maybe I'll talk about it in some other time, and I'm not really the best person to talk about it anyway. But it's really cool. I still, obviously I still have a soft spot for Scratch. And I really think the process of moving away from Scratch has, well, not just the process of doing it, the fact that I started coding with Scratch has been like really key to just the way I think about programs, the way I think about not computers, but definitely what programming is and what it can do. Like Scratch is very visual, It's this is the stage is like a big part. That's the part that people interface with. There isn't even the concept of a terminal on Scratch unless you build it over here, which people have done. But it's never like, that's not the principal aspect of it. If you grew up using computers in the 90s, like you open the computer up and it's MS-DOS and it's just a terminal and you have to type stuff in, and that is what a computer is. That's what a program does. That's the capabilities of a computer. And obviously it can do graphical things too, but that always is like, if you were a programmer in the 80s, like the graphics is a thing that is you put on top of the baseline what a computer can do. This has nothing to do with Scratch because it's kind of still like that. But with Scratch, since it's like not tied to a computer, it's not really learning about what computers do when you learn Scratch. You are learning programming, you're learning logic, but it's not like you're learning how a computer works in any way. Well, not in any way, but in most ways. So yeah, this idea of the stage and the interface and the graphics of it being very central to what a Scratch project even is, made, in my mind, that centrality as to what programs are and can do. When I first started doing Python, when I very first decided I wanted to learn a real text-based language and not Scratch, and I went to Python, and it was just a bunch of like terminal stuff. It's like, oh, calculate the Fibonacci sequence. Or one of my first projects was actually pretty cool. It went to this website, word association, and I think this one. I was for the game Codenames, which I used to play with some friends online, which is a game that you have a bunch of words. Wow. Well, I'll just look at Codenames. You got a bunch of words, you put a clue, and you want your players to guess the words that are in your team. And I was like, I bet this could be automated. And this was in 2021 or 2 or something. And I was like, there's a website here that has a bunch of word associations, and I'm going to use a Python project, which this is something you can't do in Scratch. So it's like perfect. I can finally do something that I don't have the option to do it in Scratch. Python is going to use curl to download a page, and then I would manually go through and parse the HTML. And by manually, I mean the program would do it, not me looking through the HTML. The program would look for the tags that I was looking for that has the stuff. So if I click on this and I want to download, I had to download each of these. So I had to download this. First of all, check if it exists, because not everything will exist. And then look at this number and find out what it is. Then download all of these. And then just in plain text on the HTML, all of these words are there. And then I just have a bunch of, and then code names. If I was a better programmer, I could also scrape the code names. So I could just give it the link, and then I could just scrape this and I guess figure out what team I'm on and figure out the words, which seems like, I was looking into it and I was like, can you just inspect element cheat in this game if you're a guesser, and can you just find out which words are which team? And I actually don't know if you can or not. I never found the answer to that because I'm not good at web development or web anything, sleuthing, whatever. Anyway, Python, curl, parse the HTML. Didn't use a library at all. I just like went through it with a for loop or whatever, instead of using like Beautiful Soup, which is what you are supposed to do in these kind of situations when you're parsing HTML in Python. But got what I needed. The program worked. It might not work anymore. I think it probably still does, because I don't think this website's been updated since 2004 or whatever. I'm saying that with no 2006. Okay, this website looks old, so I don't think the HTML would be changing very often. When they change the layout, it's not going to work anymore. The British spelling of savior. And then I would just cross-reference it with the words on the code names, and then it would just like figure it out. That was one of my first Python projects. what was the point of me telling you this? I forgot something about Scratch. Moving away from Scratch. When I first did Python, didn't know how to do it. I didn't know what a program was meant to do. I did do this. This is not something you could or would do on Scratch, because Scratch is for making things that are like games or like graphical things, and this is not that. This is a terminal kind of thing. You want to type or you want to just run it, and it goes to here and does it, and then just gives you. I think it looked up the associations for each word that's in this list. That's what it did. Okay. And then it would like see if any one are the same. And it's like, oh, you can give a clue for 2 of these. And that would be cool. And it did work. It took like a minute to do, because I had to look up a bunch of stuff and download a bunch of HTML and then parse through the HTML. That's a thing that you wouldn't make on Scratch because it's all like text and stuff. Like there's no visual aspect to it. You could build a visual aspect to it, but that's not the point of the program. So just the shift in what in my brain programs were, what they could do, and what they could be changed when I started using Scratch, but in many ways is still tied to this idea. That's why all my programs nowadays are like visual things. That's not true, but like a lot of them are. And because it's still what I think a program is. And I've been building all these libraries and this OpenGL version of a bunch of Scratch features, which eventually I finished, right? And then I started building some other stuff. This is what I've been doing most recently. It's all these UI elements, which are all like custom rendered instead of using document. This is like HTML kind of document stuff. Not quite. It's more gamey stuff, I guess. Control panel type elements, but I'm sure libraries exist that have stuff like this. I don't know. It's really bad too. Like if they bleed. They don't have a way to know that I'm actually clicking on the one at the top. It doesn't know. It renders it in a specific order. And anyway, it's a work in progress. It's a process. A text box is the hardest thing you've ever thought about trying to make, if you've ever thought about it. I still don't have selection. Maybe I'll get it eventually. I can do this though, and it's a Unicode text box, so I can put in characters like these, and it still works. So that's amazing, but it's a work in progress. All this stuff. I still think of programs as a visual thing first and foremost. If it doesn't have something I can see, then it feels not real to me in the same way. Even though many programs make sense in this context of a terminal and a text-based, text-based user interface and stuff like that. Yeah, and that's some of the stuff I've taken from Scratch. I no longer think in one index lists anymore. I no longer think in this way of programming where my scripts are just in random places, and then this used to be a thing. This is another feature I've heard about. So this I used to use all the time in Scratch 2. Oh god, because as you can see, nothing changes because I've done it before. But in Scratch 3 and Turbo Warp, and I don't know if Turbo Warp has a better version of this, it always put my stuff in places that I didn't want it to be. Scratch 2 seemed like it was really smart about like, it would just go here, and things would be like, I wanted to make it more like a square. But whenever I clean up blocks in Scratch 3, I think it always just like puts my blocks like here, here, here in columns, and then it's really wide horizontally, but then it's kind of like there's like a smaller one that could have fit below there and that would have been fine, but it didn't do it. Like this could go below that, and then it's the same height as this one, and then they can be side by side, and then I can put this one, and it all fits together, and I wanted to make it more like a square. I think that's the best shape for it because it minimizes the distance I need to travel when I need to get from any point to any other point, right? If I have to go all the way to the other side, and I always do this too, and God, do you remember that Scratch 2? I don't think Scratch 2 had undo. Let me check. I move this out of here. This is a terrible experience. And then I'm gonna hit Control Z. Scratch 2 did not have undo. How Did we ever use this? I don't know. And the other thing Scratch 3 has that I noticed almost immediately is that, like, if I put a number in here, and then I put something in there, and then I take it out, it's the same number. That's really cool. I love that feature. Well, I don't love that feature, but oh, this is funny. It's changing the thing. Um, that's not a thing we used to have. It'll just set it to the default value. If I change this to a 90, oh my god, this is so... I shouldn't have opened this massive project. And I put this back in eventually, okay? And then I take it out, it'll go back to 10. Almost, I'm so sure of it. Yeah, it goes back to 10. No undo, and that happening, so every time you accidentally did anything, you screw up everything. I just can't believe I used to do it. I can't believe in so many things that I used to do. I think there's a project here called Speed Test, where I would time how long it takes to do certain things. I guess this one's faster. By points. Oh, I take it back. Results are inconclusive on these. Replace item this with that. Or do it with the ceiling of that. I have no idea. Oh, I used to think I was so clever with this. I used to think I was so cool. I was like, you can put booleans inside in here, and then if you multiply it by 0.5 and then add and then subtract. Wait, that's the wrong way. If you subtract 1 from it, wait, I'm messing myself up. And then multiply it by 2. It'll be. Oh, I just lied to you. There's one you can make it 0 or 1. I forgot how. Wait. If this is a true, then it's a 1. And 1 minus 0.5 times 2. It's a 1 or it's a negative 1. And that actually ended up being pretty useful in a lot of cases. But it's so stupid. So yeah, you could like JavaScript typecast a boolean into a integer by putting it into a logic. So if I just wanted to get the exact value, I could just add 0 to it, like I've had in this situation. This will be either a 0 or 1. If this is true, it's a 0. If it's a true, it's a 1. If it's a false, it's a 0. It's JavaScript typecasting, and I thought this was so clever. And I would use these inside statements like this and be like, oh, it's saving so much time, because otherwise you have to use an if statement. And it's like, oh, an if statement. Like, look at how many blocks that is. That's got to be slower. It's probably not. I don't know. I was so concerned with speed in Scratch, and mainly that was a founded belief, in the sense that, Scratch is slow. That's another thing I forgot to mention. Scratch is slow. It's not maybe as slow as Python, which is wild, but it probably is slower than Python. It's slower than Python for most things. Graphically, might be faster than Python, depending on what you're using. If you have a good library, then no. But Scratch is slow. It's very slow for doing just normal things. It's not compiled unless you use Turbo Warp. We all know this is why Turbo Warp was invented, right? We need Scratch to run faster, and you can make it run faster if you compile it JavaScript. Cool that you can do that. I think it's not so... I'm not going to say it's not hard. I know it is a lot of work. Turbo Warp is insanely... I won't even go get into Turbo Warp, to be honest. I have no idea how it works, and I'll never understand its complexity. But what I mean is that Scratch is pretty slow, and I was so into speed. There's this project, I think, that came out when I stopped being on Scratch, but I think it's like I'm never gonna find it. It's a project that tells you the timing of every block, and it was just on one computer, so I don't know how much accurate it really is. But yeah, I was really into this optimization, trying to get as fast as possible, like encoding things, letters into numbers, so you could put them into cloud list variables, because cloud variables only allow numbers back in the day, and now they probably still do, and I don't remember. I was so into the cloud stuff too. I was like, oh, cloud variables, cloud lists, cloud database, and numbers and encoded and decoded and um, do it the fastest way you can. Use hacked blocks. Edit the JSON of your project. This is Scratch too. Used to be that. I don't know if you can still do this. Probably not. Edit the JSON and create this block, which didn't exist in Scratch too, but like make it run really fast by using one of these, and then putting like a variable in here, which I don't think you can do. Yeah, you could put a variable in here, and then you could like set the variable to a value which is the name of another variable in a sprite, or in, it would have to be a local in a sprite. And then I realized you could do it with lists, so you could put the name of a list, and you could do, I think you could put it in like these, and then you can put the variable in here, and then you can make it run really fast. And what's the point? And then you can put drop downs in your custom blocks, which I don't think you can do. Yeah, you can add a drop down. You can put a drop down of all the variables. That was so cool. Edit the JSON and hacked blocks and speed optimize, and try to like do the most on Scratch that you could. You could optimize to and have some degree of certainty that like this is the best, the fastest, the most efficient, or in some way you could maximize something with Scratch because it's so like basic and it's so locked in. This is the fastest way to do something on Scratch, and you might get exceedingly close to that. Kind of like how in simple games like Mario, there's like a fastest time you can beat Super Mario. I don't know speedrunning. I know there's like some time that it is physically impossible to beat it faster, and people get really close to it. I don't know if they've actually hit it. I think they have. I think they've done it the fastest they can in one Mario game. Scratch is like that. It has the fastest way you can do something, and it is achievable with a lot of effort, but not a lifetime of effort. With other languages, it's not so clear cut, and it becomes a game that people still like to play, but in a lot of ways isn't as useful and isn't as satisfying, because when people are doing competitive programming in C++ and they're trying to speed optimize LeetCode problems and be the fastest you can possibly be, it's like the applicability of that is that's not really the point. Is I know it's not the point, is the applicability, but it's like you get into these situations where it's either hardware dependent, there's faster ways that you'll never be able to know, there's different libraries you might end up using. I'm not doing a good job of trying to make my point here, but it's not in the same way that Scratch is, where you can get really close to that point. You'll always seem like you're really far away. Like, it's fun to do. I've never really been into it because once I switched to another language, I kind of I left that all behind in Scratch. That kind of grind set where you're like mega optimizing, or like because it just felt like it was impossible to know that you've done it, even just to know what things are faster. People are like, oh, ++i is faster than I++, and then it's just like compiler's gonna optimize it, it's gonna change your stuff, it doesn't matter as much what you do, and you never know for sure. You can't be sure that you're even making improvements. You might just be doing nothing, and oftentimes speed improvements comes at some other cost, and in Scratch it's probably the same way, but like, and then there's all kinds of stuff that it becomes, in my opinion, more of a fool's game to go down that path, because you want to have the best, you want to achieve the best and have it run the fastest that it can possibly run, and only in very small cases of small and simple programs can that really be done with any degree of certainty. past that point, it just becomes like not worth it. And not just not worth it, it's unsatisfying to try to keep doing. And it's sad that that's the case, but that kind of has to be the case because programs are complex, compilers, assembly, like the CPU is going to run your thing, so the architecture matters, the pipelining, the caching, and like all of these things compound to make it not possible for you to, like, you can benchmark it and you can benchmark a different version and it's faster and you could be like, that's good. But you can never know that you're actually done it the best way. There probably isn't even a best way. And that's sad because, you know, I'd love for the world to be simple and just have better ways of doing things. And then that way is worse because it's a little bit slower. And if you do it this way, it's like a clever solution. It's like everyone loves a clever solution. In math, in computers, it's like the unexpected clever solution that solves the problem the best way. And then everyone's happy. But in the real world, it doesn't really work like that. It's always interpretation and ideals and objectives and differences and all kinds of stuff. And there's no universality to it. But in Scratch, there's something much closer to that. And because of it being such a small, contained environment, there is a sort of universality to the fastest way you can do something. So it may be worth your time, but not for me. At least not anymore. I used to do this wild thing. I would use multiple variables and increment them at the same time. Let's see if we can find it. Let's see. It's got to be one in here. If only you could, like, oh yeah, you can rename variables in Turbo Warp. And maybe in Scratch too. I actually don't know. You definitely couldn't here, could you? You can. You definitely can. Okay. I was lying to you. Sorry, I was looking for an example of me doing not quite this, but not quite this either. I'll just make it. Here's this fun Scratch. Imagine I wanted to do this, but it's +1. Here was my actual thought process that I think I tested and I wasn't sure what the conclusion of that was. Here is my actual thought process of doing something like this. I was like, ooh, this plus, so all of this is like optimal, right? Like there isn't a faster way to do any of this in Scratch. So this, I can say that this, but except for one thing, this +1, like this, technically, if I didn't have to do a +1, right, I would be faster because it doesn't have to do the math, right? The math is hard. It's not hard. Computer can do it instantly, but it is still some amount of time. So I was like, okay, what if I could avoid doing the math by doing this? And then I would increment this here, and then I could put this here, and then set that to 2 at the beginning. And now we don't have that +1 anymore. So I don't know, because then I added this, right? I have to change this one in addition to this one. So it's like, is this faster than doing +1? And it definitely isn't. Actually, okay, I can't say that with any degree of certainty, but I can't imagine that this, having another variable here, would be faster than doing a +1, something that is so trivial. But it wasn't just +1, like maybe it was ×2 +1, and then maybe it's squared, and then joined with another thing to make it 0.02, or like, that wasn't a point. At some point, it does become better to have this other variable. And at, like, there's some threshold where it's like, where the variable is more efficient, or it's faster, or the addition is faster, the computation is faster. And I was so interested in like finding that, and I wanted to know exactly how many pluses was like a change, or how many multiplications by -1, or you know, what level of computation would equal a variable, or how slow are variables, compared to lists. Should I just use a list instead of variables? And instead of having variables, I could just have item x in list, where x is just a number and the number is like a variable, because a list is just infinite variables. Is that faster? I think I tested all this stuff, and I don't know what the result is. Um, and because I wanted to do it the best, and if you really want to do it the best, you do these kinds of things because it matters, even though it matters so imperceptibly little, and it makes your code so much harder to understand. But if you were really going for speed, these are the kinds of investigations that are worth your time. And it's a little bit like, I like that idea. It's such a romantic idea that I could find the best way to do everything, the fastest way to do everything, and then just be like so good, and it would just be so optimal, and I would know that everything is done in the exact best way possible, and it's just such an ideal world, right? Um, it's sad to find out that that's not possible in most coding environments, and um, it kind of like, the some like you feel like you lose a little bit of some kind of quality when you figure that out. And so that's like Scratch. That's yeah, Scratch. I don't have much else to say about it except tomorrow, when I'll think of a whole bunch of other stuff to say about it. Maybe we'll just talk about some old projects that I used to enjoy, and some people I used to talk to, and some memories I used to have. I don't know how long I've ever been recording. I still can't know because it doesn't say on OBS. Oh, it does. It's been 1 hour and 7 minutes, and that's way too long. But I'm gonna upload it anyway. Is there anything else I want to say? Don't think so. We'll leave it at that for now. Yeah. See you at some other time.